Hello, good morning. Welcome to this lecture on word embeddings and Word2Vec in natural language processing. In this lecture, we are going to learn what is word embedding, how to generate word embeddings from given text, and what's the application of Word2Vec model. Uh, you will be able to understand. So let's start with word embeddings. This technique has been introduced to create a word vector for each word in a sentence, and specifically if you are looking to predict the next word or the target word, so you need to generate word vectors to work with the multiple dimensions present in the text. And here the interesting part is it is trying to capture the similar meanings between words, and the words which are closer together in the vector space will be having similar representations. So the word embedding model will learn from logic Agora, and it is used to improve the efficiency and effectiveness of natural language processing tasks, mainly in tasks like natural language modeling and sentiment analysis, machine translation, information extraction, and information retrieval. In such kind of NLP task, it can improve the performance of the model. Now, you should understand why we use this technique. So, if you compare one-hot encoding with a word embeddings, one-hot encoding represents words as discrete symbols, discrete vector, and does not capture the relationship between words. For example, the words cat and dog would be represented as different vectors, but these two words are closely related to the animal category. But in word embeddings, it represents words which are having similar meaning with a similar representation, and it creates a better representation of data. And in one hot encoding, the words are represented in a sparse vector format where uh, the dimensions of the vectors will be equal to the size of the vocabulary. But in word embeddings, the representation of vectors in a lower dimensional space may have word specific dimensions 100 or 200 or more than that, so it is much faster and more efficient. So this word-to-word model has been introduced by Google in 2013. So it has been developed by Thomas Michelov, and it creates a word vector representation using neural network model. So the neural network is trained to learn words based on the similarity measures, similar representations. So it uses surrounding words to determine the target word. And there are two models or two architecture in this which you can use to train the data. So we have a continuous bag of words and skip gram. We will discuss in detail about this too. So first, let's start with this continuous bag of words SIBO model. It predicts the target word for a given set of context words. For example, we have the context words the cat sits on and the. So for this given context words, it predicts the target word as mat. But in skipgram model, it performs the reverse operation, that is, it predicts the context word, surrounding words based on the target word for a given target word. For example, here the target word is mat. For this particular target word, it predicts the context words such as cat, sits on, etc. So these are all the context words predicted by the model. Now, If you compare these two models, skipgram works with the smaller data set, and it is good at working with rare words. Rare words are less frequent words across the corpus, whereas in SIBO we use more efficient. SIBO is more efficient for large data sets in which there may be multiple frequent words, so it can handle based on the frequency of the words. Now let's see how it works, how this model works. Let us use skipgram to determine the context words for given target word. Let's consider two sentences in this corpus. That the first sentence is the cat sat on the mat, and the second sentence is the dog sat on the mat. Now, given this target word sat, it generates the context word cat on with a window size of 1. So that means one word before the target word is set and one word after the target word set is considered here. So the learning process uses neural network model. We apply a backpropagation technique and stochastic gradient descent to predict the vector target words, and to adjust the weights. We are using a backpropagation technique. So if the error is maximum while predicting the context words for the actual words, so it will try to reduce the error. After many iterations, it will generate meaningful representation of vectors. For example, this will be the output for cat, dog, and sat. We are getting this vector representation. These are the predicted probability values for each of the surrounding words. And these vectors are represented in a high dimensional space where the words are closely related to each other and having a better similar representation, vector representations. For example, the word cat and dog are closer to each other, having more closer representations, more similar representations in the vector space. And let's now discuss mathematical aspect of Word2Vec. So it represents words as vectors by analyzing a similar relationships present between words in a large corpus, and it gets a similar representation for this in a vector space. So when you use gram, it predicts context words for the given target word, and the training process uses neural network to update the weights and minimize the error based on the probability value of predicted value. So now there is an objective function behind this operation in skipgram model. For a target word, it predicts context words. We know the objective function is created as probability of context word vector representation given for the context words. So you should first give a target word. So for the given target word, it predicts the probability of WC, that is context words. Probability of context words will be calculated. So it is calculated by applying these exponential functions. So we take the transpose of vectors of context words, and then you should take the vector of target words. You should take the dot product of these two and divided by sum of the transpose of words vectors. So here we are taking transpose of words vectors from the vocabulary set, and for the given vocabulary set, so we are taking the vectors of transpose, and then vector of target words are taken. Dot product of these should be calculated, and we are getting a probability values of all words in the vocabulary. So that's at the denominator. So this is computationally expensive. To reduce the computational complexity, we go for negative sampling. For negative sampling, it considers a sample with a few negative words. So these negative words are unlikely to appear in the given proper context, and the models adjust the weights accordingly to improve the uh, predicted output. So this process makes the approximation more efficient. So it improves the training process. It improves the training process, reducing the time taken to approximate the value, probability value. So we apply a softmax function at the dense layer to predict the output. So in any neural model, we have input layer, hidden layer, and output layer. So when we apply a back propagation, it adjusts the weights by checking if the deviation is maximum. That is, if the difference between the predicted and the actual is maximum, then it will reduce the error. Through multiple iterations, we try to improve the performance of the model. So after training, we are getting the better word vector representation that captures similar meanings between words. For example, if you have the word vector of king 001 and word vector of man 100 and word vector of women 010, something like that, then we get the word vector of queen 1111. So like that we are getting it. Sorry, not 111. So since we have 100, then 010 001, so we will be getting 1 minus 1 1. Like that we are getting the vector for queen. So the applications of this word is multiple areas. You can see here it can be applied in text classification to classify the text as news text, sports news, or business news, some financial news, something like that. And we can have predefined class labels to classify the given text based on the words vector. And in similarity analysis, you can predict the sentiment of words. The words can be classified as positive or negative or natural. For example, anxiety or happy, or unhappy. So like that, it can predict the sentiment for a given text. In machine translation, it performs a mapping between source language text and the target language text to analyze and predict the proper target representation. So it uses a Word2Vec model for that. And in information retrieval, we use word embeddings to retrieve documents relevant to a query. So based on the relationship between words, it will determine what are all the relevant documents, and based on that, it will generate relevant information and relevant documents. So named entity recognition, we apply Word2Vec model to identify and classify entities. Named entities may be organization name, location name, or person name, other entities names in the text. So we can biomedical applications also, we can classify, for example, disease names, disease as COVID-19, or a disease as viral disease, specific viral disease, cholera, or viral fever, something like that. So it has many interesting applications. We can also find applications of this uh, in various other fields, information extraction, and even in topic modeling. So let's now discuss core part of this model. We use GMSIM for this example. So we should import this Word2Vec from Gensim model, and we are creating a sample corpus that contains two sentences, and the sentences are represented as vector form. The sentences are represented as a list form, and we are now training the Word2Vec model. So calling this Word2Vec class, we pass sentences and vector size is specified over here, and window size is 5. That means 5 surrounding words will be considered, and minimum count of is to be at least one. It should, that means the word should appear at least one. Then workers, we are going to use 4 cores to run the model in parallel for multiple vectors. So this model is trained to predict the words, and for the given word, say cat, it is generating a vector representation, and the vector gets printed, and it finds similar words to cat here by using most similar function available in this word vector model. It is predicting top 3 items which are closer to each other in this context. So these the three words which are similar, which are closer to the word cat, would be printed as output. So that's all in this lecture, guys. You have learned how to create a word vector representation as continuous vectors, capturing the similar meanings with this. How to create a representation of words we have understood, and also you have understood how to apply skip grams, to learn word embeddings for various NLP tasks. So you have understood all these things. I hope you will apply this for various NLP tasks, and I hope that it will help you in doing your project more effectively. Thank you all.